video is in continuation of the earlier video on surd. There I have explained the definition of surd, the basics, what is the related terms which will define surd, the rational and irrational numbers. Now onward, I will discuss the symbol of a surd, explain the different terms that will explain the surd itself. To familiar with, I will write here a common representation of surd. So this is one kind of surd where n is belongs to an integer and x also belongs to an integer, but it would not allow, or it would not be a part of where x value is 0 or 1. So that means x cannot be 0 or 1. For that, it won't be a surd. So now in here is named as order of a surd. Okay, and this is called the root of x, means nth root. I will read it like that: nth root of x, where x is an integer not equal to 0 or 1. So I will read it like that: nth root of x, where x is an integer not equal to 0 or 1. So this is a classic model of representation of surd. So this can be written as like that. So this also can be represented in the form of, because anything under root of any order, whenever it is represented as power, this is also we call it power. Okay, index or power. So these are represented in other form like that only. X to the power, we'll say x to the power 1 by n. So this is also called index, because index generally when it comes in not in fraction, rather in integer. Let's say if I say x square, so here 2 is index. In this form it is called the order. This is the basic difference, but you can call it index or power 2. Okay, no issue. So this is the basic form of a surd. Now come to the different kind of surd. Kinds of surd. Okay, so why it is necessary? Because it is not that whenever you will do or solve any mathematics, you have to remember all kind, otherwise you will not able to solve. But thing is that to clear the basics, you need to know why and what are the difference between the different kind of surds. So if I write, there are few many. One is simple, then then we can write compound, then mixed, then similar, dissimilar, and binomial, simple, compound, mixed, similar, dissimilar, binomial, and other one is Another one is, oh yes, pure. These are the some kind of surds. I can tell you the different different definition or different kind of surds that would represent these terms. Means simple, compound, mix, similar, dissimilar, binomial, and pure. Now, starting with simple. Simple is a kind of the basic surd where only one term is there under the root. Let's say it is root 5. If I say this is the only one term there inside the root, it could be 2, 3, any number, then all kind of such surd are called simple surd. That means only one term is there because this consists of only one term, and this is the simple surd, we can say. Okay, that means if I say that root a plus root b, like that, two terms are there, then it is not a simple surd. So to distinguish with, we can have this kind of example. So this only root 3, root 5, root anything like that is a simple surd. Now come to compound surd. Compound is that where two simple surd will club together with the sign of multiplication, addition, subtraction, division kind of signs. So that means if I say root 5 plus root 3, so this is a compound surd. Okay, anything you can say plus minus or root 5 into root 3, these are all compound surd. Okay, now you can say that compound surd, this if I multiply, it will give you root 15. This can be converted into a simple surd also, but this in general are called the compound surd. Okay, now come to the mixed surd. Mixed surd, this is kind of surd which is mostly almost similar to the compound surd. Only difference is that it is consist of a integer plus a surd. That means if I write 2 plus root 3, it is a mixed surd, whereas if I write root 2 plus root 3, it is a compound surd. So that means if any integer comes in place of a surd along with a surd, then it is a mixed surd. Okay, now the next part is your similar surd. So for similar surd, or you can understand that similar means you are comparing two surds together. To define it as a similar means two surd, if it is like that root 2 and 6 root 2, these are called similar surd. Why? Because this root 2 and 6 root 2 have a common factor, common surd factor. Means it should have a common surd factor. Here it is equal to root 2. This root 2, 6 root 2, if such surd are there together in any sum, so this may be defined as a similar surd, where these surds have a common surd factor, root 2. Okay, and similarly, if I say the dissimilar, it automatically comes to your mind where the surds doesn't have any common surd factor. That means root 3 and root 5 doesn't have any common surd factor, then it is a dissimilar surd. Understood? So next come the binomial. So binomial is that surd where the main you can say the value, the integer value for which we are calculating the surd have are same, but their power is different. That means if I say 2 to the power half and 2 to the power 1/3, then these two values are same. That means those are same. Now if those are same, then we can club together to add the powers together to get a common surd. That means a simple surd. So in this case, if I multiply or divide this kind of surd, means individually those are surds now. Or let's say I am taking the simple example 2 to the power yes, it is okay, 2 to the power 1/3 into 2 to the power 2/3. Okay, now this 2 to the power 2/3, that means is nothing but the cube root of 2 here 2 square cube root of 3. So that means this 2 is common for both. If I am not converting into 4, that will be a multiple of 2 altogether, but initial stage it is 2. So that means if 2 and 2 are same, then instead of doing any calculation, I will straightway bring 2 here and I will club, because the multiplication rule where the power will be summed up. So that means I will write 1/3 plus 2/3, that means 2 to the power 1. So that means the binomial surds are those surds which can be converted into a single surd or simple surd. Okay, so where this value are same, the power are different. So these are called binomial surds. And the last one is pure surds. Pure. Pure surd is nothing but similar to the simple surd, but thing is that this is purely a surd. Means if I write root 3, it cannot be a mixed surd. That means if I write let's say 12, root 12, so that means it would give you 3 into 4, whereas 4 will come out as a integer and it will bring a 2 outside the root and 3 will be there. So this is not a pure surd. The pure surd is root 3 only. So 2 root 3 is not a pure surd. It is a mix of integer and surd. So it is a combination surd only. So this kind of surd is called pure surd, where only surd will be there in the term. Okay. Now I think you have understood the different kind of surd. In the later video, I will come with some kind of you can say the rules of the surds, so that you will able to solve the bigger problem. These are the standard rules that will help solving the problem related to the surds. So as of now, just go through the classes, the earlier class and this class, to understand the basic first. Then after when I will move, that will be easy for to understand the sums and sums together, means different kind of problems I will explain. And in the next class, I will first explain the rules, then after I will solve some problem. Okay, thank you.